So we're going to work a few application problems now that involve basic right triangle trigonometry. And it is kind of amazing how much we can already do with just the little bit of trigonometry that we know, and how much basic trigonometry can be applied in a useful way. So let's take a look at this problem. Now, the exercise 11 through 14, those are all applied problems. So there will be several videos about these word problems. And calculator is required for each. So exercise 11, a 22-foot ladder leaning against a building makes an angle of 70 degrees with the ground. How far up the building does the ladder touch? So let's see if we can draw a picture to describe this situation. So we got our ground, and we got our building. And then we got this ladder from the ground reaching up the side of the building, and it makes a 70-degree angle with the ground. So you want to make sure you get your angles labeled in the correct position in these word problems. Since it makes an angle with the ground, we need the ground to be one side of this angle. I think it's pretty clear we're talking about 70 degrees right there. And we know how long the angle is. We know that, I'm sorry, how long the ladder is. It's 22 feet. And we want to know how far up the building the ladder reaches. We want to find that height right there. Now, sometimes I draw a kind of artistic or not so artistic picture to describe the situation. I would draw a separate picture too that just sort of pulls out the essential information. So we have this ladder that's 22 feet. We have a 70-degree angle right here. And we have a right angle here. We're assuming the walls of the building are perpendicular to the ground. And really we want to find that length, that height, x, right? So let's see, I have an angle. I have the hypotenuse of a right triangle, and the opposite side of the side opposite the 70-degree angle is the side I'm trying to find. So opposite hypotenuse kind of makes me think of I choose to use the sine function. Often there's more than one function that could be used, and sometimes you can choose a different angle too, because we really know what this third angle would be in the triangle, since we have a 90 and a 70. But again, I'm just going to choose one route to follow here. So I'm going to use sine. Sine of 70 degrees is equal to opposite over hypotenuse is equal to x over 22. And so we got to solve for x. And now you can either work with the expression sine 70 degrees to the end, or you can insert a decimal approximation immediately. I'm going to go ahead and insert a decimal approximation. Make sure your calculator is in degree mode. And let me see, mine is, I see the little word degree up there on the screen. If you're not sure what degree mode means, please check with me. So then I just do 70, take a sign, and I'm going to have to round off that decimal. Now, if you want to just work with your calculator and not write anything down, that's fine. You can just round off your final answer at the end. But for purposes here, I'm going to round off at four places, so I get 0.9397 rounded off. at 4 places equals x over 22. Now, I don't have an official rule on where you have to round off values in this course. I recommend 4 places for trig function values to get reasonable accuracy, but I'm not going to zing people if they don't get exactly the same answer as I do. In fact, if you work with more decimal places, you'll get a more accurate answer than the one I'm getting here. So multiply both sides by 22. So I have 0.9397 times 22 is 20.6734. So 20.67 feet is approximately and very close to the value of x that we want for this problem. I will accept answers that vary slightly from that, and I wouldn't take points off as long as you're close. Because if you round off at a slightly different point in a problem, you may be doing everything correctly, but it could make the answer look slightly different.